Okay, in this section, we're going to take a look at how to solve absolute value equations and inequalities um, graphically or using the number line. So we're going to do the exact same thing we did in the previous section. This time, though, we're just going to use the number line specifically to see if we can't come up with the solutions or the solution set quickly. So once again, let's remind ourselves what absolute value represents. So the absolute value of a number x represents the distance between that number x and 0 on the number line. So how far is the number from 0? So the absolute value of any real number will just give you, when you do the absolute value of any real number, it'll just give you how far away from 0 it is on the number line. So something to think about. The absolute value of x would be exactly the same thing as the absolute value of x minus 0. And like we just said, the absolute value of x is the distance between the number x and 0 on the number line. And it turns out we can modify this and get absolute value expressions that represent other distances. So the absolute value of a number minus another number, it turns out, is going to represent the distance between those two numbers. So in general, if you've got a variable that is holding the place of a real number, and if you have a constant that's a real number, the absolute value of x minus c will represent the distance between the number x and the constant c on a number line. Just as up here, the absolute value of x minus 0 represented the distance between 0 and x on the number line. So it doesn't have to be 0. It could be x minus some other real number, and then the absolute value of that will be the distance between x and that number on a number line. So for example, if you have the absolute value of x minus 3 equals 2, one of the equations we learned how to solve in the last section. On the number line, what this represents is the distance between x and 3. So we see that right here. We have absolute value of x minus 3, so that'd be the distance between x and 3 on a number line. But it is 2, it equals 2. So the distance between x and 3 is 2 on the number line. So since it equals 2, we actually know the distance between those two numbers on the number line. So what this allows us to do is solve absolute value, in this case, equations, fairly quickly. Not really any quicker than we did in the previous section. So it's just kind of like having an optional second way to solve equations such as this. So once again, we've got the absolute value of x minus 3 equals 2. So this equation in words just says the distance between x and 3 on the number line is 2, and then we're being asked to find x. So what is x? And as we know from the previous section, there's going to be two answers. So let's see if we can't figure it out. But this time, let's actually just use the number line and not actually solve it algebraically. So if this is 0, and we got 1, 2, 3, 4, 5, 6, and if we need some more, we'll add more numbers later. So let's see, the distance between x and 3 on the number line is 2. So 3 is one of the numbers we know we're interested in. So let's just kind of keep track of that. So here's 3. So we'll just kind of start right here. And we want the distance to be, so we want the distance between 3 And the number x we're trying to find, we want that distance to be 2. So all we're going to do is we're just going to go 2 units away from 3. So we'll go 1, 2 units from 3. And we'll go 1, 2 units the other direction because we want the distance to be 2. So as long as we're 2 units away, either direction will work. So the distance between 1 and 3 is 2, and the distance between 3 and 5 is 2. So this distance right here, that's 2 units, and that's 2 units. So what we did by looking at this number line is we just figured out that if x equals 1, or if x equals 5, both of those are 2 units from 3 on the number line, which is exactly what we were supposed to find. And you can plug them in and check. So 1 minus 3 is negative 2, and the absolute value of negative 2 is positive 2. And if you plug in 5, 5 minus 3 is 2. The absolute value of 2 is positive 2. So those are the two x values that we wanted. So our solution set would be all x such that x is equal to 1 and 5. So we solved that equation, but we didn't actually solve it algebraically. We used the number line to figure out which numbers are 2 units away from 3. Okay, so let's go ahead and just remind ourselves that we can solve this algebraically. So we didn't have to use the number line. So what we're essentially looking at is just another way you could get the answer. So in the previous section, we learned how to solve this algebraically. So let's just show ourselves that we would have got the same answer using what we learned in the previous section. So the absolute value of x minus 3 is either x minus 3 or the opposite of x minus 3. So we add 3 to the other side and get 5. Divide both sides by negative 1. And then add 3 to the other side to get positive 1. So we get 1 or 5. So our solution set is still 1 or 5. So we would have got the same thing solving it algebraically. You don't have to use the number line. We're just looking at another alternate way to get that same exact answer. Okay, let's see how this would work for an inequality. So it's going to be very similar. We're just going to have to think a little bit more. So this inequality basically says the distance between y and negative 2 on the number line is less than or equal to positive 3. And then basically we're being asked to figure out what is y. Now notice I said it's the distance between y and negative 2. And you might be thinking, well, I don't see a negative 2. So let's go remind ourselves. If it's x minus c, that represents the distance between x and c on a number line. But in this example, we don't have y minus anything. I've got y plus 2. So we're just going to have to use a little rewriting. So we have a minus here. So this would be y minus negative 2. So we know that minus and negative is really plus. So now it's y minus our number, negative 2. So with that minus in there, then it's the distance between y and negative 2. So y and negative 2. So if you have the variable plus something, just rewrite it so it's minus. That way we know it's the distance between this and this. Well, let's see if we can't figure that out. So let's draw a number line. So here's every single y value. Let's see. If this is 0, we'll have 1, 2, 3, -1, -2, -3, -4, -5. Alright, so let's start with -2. So we want the distance between y and -2. So let's start here. And we want the distance between y and -2 to be less than or equal to 3. Well, let's start with the or equal to part. So if the distance was 3, then we would go 1, 2, 3, 1, 2, 3 units away, 1, 2, 3 units away. So +1 and -5 are exactly 3 units away. But we want the distance between y and -2 to be less than that or equal to that. So if it was equal to 3, we'd be at 1 and at -5. But less, if we have a distance that's less than that, it'll also work. So basically that would be all the way out to -1 or all the way back to -5. But any distance less than that will also work. So less than that would be things that are closer to -2. So that would be all of those numbers also. So this distance right here is 3, and this distance right here is 3. So we just went 3 units out because our distance can be equal to 3, and then we want and then we want all the numbers less than. So all the numbers whose distance is less than that. So that would be stuff even closer to -2. So we end up with everything from -5 up to +1. So our solution set would be the set of all y such that y is between -5 and +1. And they can be equal to -5 or +1 too. So we end up with that solution set. And then there's our graph of the solution. All right, and once again, let's remind ourselves that you don't have to use the number line to solve this. You can solve it the way we did in the previous section. You can actually still solve this algebraically. So we can still use the fact that this is than. So less than is like and. So remember, less than would be an and situation. So we end up with the absolute value of y plus 2 could either be y plus 2, or it would be the opposite of y plus 2. And this is an and. So we subtract 2 from both sides, divide by -1, subtract 2, and then we graph it on the number line so we can see our solutions. So we want to be less than or equal to 1. So equal to 1 or less than. And then we want to be greater than or equal to -5. And we want the overlap. So the overlap is right here, which is exactly what we had. We had everything from -5 up to +1. That's what we just got a second ago. So our solution set is all y such that y is between -5 and +1, including -5 and +1. So we had the same thing using what we learned in the previous section. So what I'd like you to keep in mind is in this section, you're just learning an alternate or optional way to solve an absolute value equation or inequality using the number line. So what we learned in the section before, the algebraic way to do it, that still works. It's perfectly okay. You can still use that. This is just another way you could come up with those solution sets.